Assalamu alaikum wa rahmatullahi wa barakatuh, and peace be upon you all. My name is Khamis Minshawi, and I'm partnered with Manaz Riyas. Our project ID is 713D, and our project title is called Real-Time American Sign Language Recognition System, which is supervised by Dr. Narlia. So over here, the poster is displayed, and we are going to be explaining about each segment. The first section over here is the introduction. In today's world, there has been an increase in the number of deaf and dumb people due to the growth of the population each year. According to the WHO, it is estimated that by 2050, over 700 million people, or 1 in every 10 people, will have disabling hearing loss. However, fortunately, there have been many technological advances that can assist the individuals while using the internet. Deep learning and computer vision may also be used to help with the cause. This can be very useful for deaf and dumb people in communicating with others since sign language is not something that everybody knows. Furthermore, this can be applied to the development of automated editors in which an individual will only need their hand movements to write. So therefore, in this project, we are going to build a sign detector that recognizes numbers from 1 to 10 and may readily be expanded to cover a large array of other signs and hand movements, including the alphabets, which we have developed. So the problem statement, in the first point, sign language requires a lot of training to be understood, and so not everyone will be able to understand what the gestures really mean. Second point is, we know that there is still a communication barrier between the hearing/speaking impaired and the hearing/speaking majority. And the third point is, to help bridge this communication barrier, our proposed system will be able to translate basic sign gestures into readable English words. The objectives for this project is to create a system that will be able to bridge the communication gap between hearing/speaking impaired individuals and the rest of society. Moreover, the second point is to assist hearing/speaking impaired individuals by helping them effectively communicate with people face to face and online through video calls and meetings. And finally, to build a system that can interpret sign language gestures using machine learning and image processing. Moving on to the project's significance. Our project's goal is to assist hearing/speaking disabled people in their everyday lives, such as in online classes, meetings, and even video calls. The proposed system will have various amounts of information stored in advance, as well as real-time data collected from the sign detectors when utilized. It will facilitate communication between those who are deaf or unable to hear properly and other individuals during online and face-to-face interactions. That's it from me for now. Brother Manaz will be taking over from here.
Assalamu alaikum. I'm Manaz, and I'm going to talk about the methodology for our project. In the process of converting sign gestures into readable English text, we have three main stages. The first stage is image capture. In this stage, we create the dataset. So we capture images using the laptop web camera, and each image will contain different sign gestures. Ideally, you want to use a high-definition camera with good lighting conditions to capture the dataset, but in our project, we just use the inbuilt laptop web camera. The second stage is image pre-processing. Before this dataset can be used to train an ML algorithm, several adjustments need to be made to the image dataset, like cropping, labeling, and brightness adjustments. To crop and label the image, we used an open source image package called Label Image. This package allows us to crop and label the image and also create corresponding XML files to represent each gesture. This is important because the ML algorithm cannot directly be trained on IMG files, but it can be trained on XML files. Then we split the XML files into training and test data, one for training the algorithm and one for evaluating the algorithm's performance. And then the final stage is feature extraction. So after the images have been captured and then processed, the image is now ready for feature extraction. This is done by using a machine learning algorithm called CNN and a machine learning technique called transfer learning. These are the tools we used in our project: Python to code the project, OpenCV to capture images in real time, Keras and TensorFlow. These are both open source Python libraries that allow real-time object detection. So in this case, to recognize the sign gesture, we use these two. Conclusion: we used CNN in conjunction with transfer learning for recognizing and classifying ASL words in real time with a webcam. So unlike other projects that use a huge data set, we used a very relatively small data set, and also a lot of the other projects use very expensive kinetic gloves, um, but our model just uses the inbuilt laptop web camera and achieves a similar level of accuracy to those models. And then in the future, this model can be expanded to recognize even more words and potentially other sign languages as well.
So that's all from us. Thank you for tuning in, and Assalamu alaikum wa rahmatullahi wa barakatuh.